Hello guys, so let's start with the data types. So we'll first see what data type means, then we'll go to the different types of data types, and then we'll do one set of data types. The next we'll cover in the next video. So let's start. What is data type? So data type is something that tells the computer what to interpret of the value that is given to it. Variable, what is variable? It is just a memory location. It is the alias name of memory location. So that is variable, and the value we give to that variable is interpreted by the interpreter. So what value it is, that is denoted by data type. So that is data type. We'll get to know more in detail when we move forward in the video. So let's just get into it, dive into it. So different types of data types. So broadly, there are two types: fundamental and derived. As the name suggests, fundamental means the building blocks of any language. So these are the building blocks, and using these building blocks, the derived data type is made. Okay, so fundamental are of 5 types: integer, float, complex, boolean, strings, and derived are of 6 types: list, tuple, range, set, frozen set, and dictionary, which we will cover in detail in the videos ahead. So let's start with integers, which is related to numbers. We all have studied integers in our high school. So integers are whole numbers without any decimal. Like specifically when we take Python or any programming language in point of view, so integers are whole numbers without any decimal point. Okay, so that is integer. We have 4 type of integers when it comes to Python or any programming language. So they are differentiated on the basis of base number. So first we'll see the name, then we'll see it on Jupyter Notebook, that how they are differentiated. So this is decimal, binary, octal, and hexadecimal. As the name suggests, decimal means deci is related to number 10, bi means 2, octal means 8, and hexa means 16. So if we use the vocab and find the actual meaning, we'll see that how it is related to the number associated with it. So as I said, decimal. So let's start with decimal. So decimal's integer says that it has base 10, and as we already said that it has a relation. So the base 10 means that it will have 10 numbers used in it. So it is 0 to 9. That means the base. And to declare any decimal, we don't need any prefix. I've declared a simple number, I've printed the number, and I've printed its type, and it shows integer. Every output will show integer only because these are the parts of integers. So decimal, binary, octal, and every hexadecimal, all are part of integers only. So the type will show integer only. Let's move on to binary, which has base 2. It will take only 0 and 1. So I cannot input 1, 0, 2, 3, 4. I'll have to change it to only binary digits, that is 0 and 1. So I gave it 1001, and I added a prefix, that is 0b. B can be capital or lowercase, and it will interpret the value according to binary. So in binary, 1001 is 9, but in integer, 1001 is 1001. So that's how different bases system work. Next we have octal integers, which only has 8 numbers, that is from 0 to 7. So I can use 1001 because it has 0, 1, which are the part of it. So I'll just change the B to O, because to declare an octal integer, I need to add a prefix, that is 0O. And it gave me a different number. So 1001 is 513 in octal integers. Let's move on to hexadecimal. Let's see what it shows. So it has the base of 16. It takes characters, that is 0 to 9 and A to Z. Actually, I made a mistake in here. it does not take characters from A to Z. It takes character from A to F. So we'll see that later. I just corrected it. So it takes the prefix O0x. So it shows that this number is 4097, which is a completely different number. So every base system interprets the number differently. So let's now move on to base conversion, which means converting one type of integer to another. That means converting hexadecimal to binary or binary to octal. We'll see that. So for that we use functions. Functions are very easy. We'll see them in detail. These are like predefined functions that we get in Python. So let's just take the hexadecimal integer that we took in the last cell, and I have used a function called bin. If you see in print, I have written bin, and then in the bracket I've added a. So if we convert this hexadecimal into binary, it gives us this huge number. So that is how conversion is done. To convert any number into binary, just use the function bin. To convert any number to octal, use the function OCT, oct. That is used to convert any number to octal. So let's just take so we converted it, and it's also some different number. Now we're converting binary to integer. So we converted it, but there's no point of converting any of these number into integer, because the value we get by using these number is same as the value that is already printed. So we get integer value only, that is for decimal. But to convert it into hexadecimal, octal, or binary, we use the functions. Integer, by default we get decimal value only, and all of this is integer only. So we don't use int function that frequently, especially while converting hexadecimal to octal and everything. We use it when we have to convert it from decimal to integer. That time we use int function, otherwise we don't. So now that we have done integers, we have covered all the decimal and everything. So our integer part is done. So let's move on to the next, that is float. Let's see what float is. So while we did integer, we saw that it does not include any decimal. So float is that data type which has decimal numbers. So all the real numbers with decimal points is called float. Very simple. Wherever you want to add decimal, use float. And we don't have to add any prefix for it. We'll see it in the Jupyter Notebook. So float data type. We are in the Jupyter Notebook. So as we discussed, float just has decimal points. So here I just added decimal point and I printed it. It is going to show me float. Because it has decimal point, it is going to show me float. Otherwise, it would have been integer. If I would have written 0.0, then also it would have shown me float. Moving on, let's see complex numbers. Complex number were the part of our class 10 syllabus. But if you don't remember, let me just give you a little glimpse. It's a combination of real number and imaginary number. So what is imaginary number? It's under root minus 1. That is imaginary number because we don't have any value of it. That is why it is imaginary number. So here I've shown it in a more understandable way, and it is often written as a plus b, j or I, whatever. You can use j or I, whatever you like, wherein a and b are real numbers and j or I have used I here, so I'm going to write I only. I means minus 1, under root minus 1, which is an imaginary part. So for complex number, what we do is we use a function to declare or to given complex number. We use a function, and this function is very easy. It's called complex. It takes 2 parameters, that is x and y, which includes the value of a and b that we discussed in the notebook, where I showed what real plus imaginary. So that's the a and b that goes in the parameters. See, here I've shown you. So that a and b value we put in the complex function. We'll understand function in detail later on, but for now you just get that we entered two values in that bracket and what those values are. So it has given me 5 plus 4j, which is a complex number. So now you understand what a complex number is. That's how we declare a complex number. Let's move on to the next, which is Boolean. Boolean is the easiest data type to understand. It has like two values. That means it is either going to be true or it is going to be false. So we can represent that using true, false, or 0, 1, or we can use any integer and 0, wherein 0 is false and everything else is true. Let's just see. So I've written a is equal to true. I had to do it capital because it takes capital as the true value. It has given me the result as it belongs to bool value. It is bool data type. Bool means Boolean. It's short for Boolean. Now let me just write another number. So I've written -1. So it is giving me true. Because if I write any value other than 0, it is going to give me true. See, with any positive, negative, any number. If I give any number other than 0, it is going to give me true. But if I give 0, it is going to give me false. Right? Is that, that is very easy concept to understand and everything. Boolean is very, very easy. So let's move on to strings, which is the last part of the fundamental data types. So string is a combination of characters. Various characters in either single quotes, double quotes, or triple quotes. The uses of these quotes will be discussed in the coming section in just 2-3 minutes. So that part is going to get clear. So what characters are included in this? So it has like numbers from 0 to 9 or anything. You can add any number and you can add any alphabet, capital or lowercase, whatever you like. And special characters like asterisk, exclamation, question marks, spaces. You can add anything in this. String can include anything. Anything you like, you can include it. Okay, so that is string. To understand it more clearly, let's move on to the Jupyter Notebook. So let's see what it has. So string, I'm just declaring a very, very simple string, which is hello world. And to declare a string, we use quotes. So I've used double quotes. And if you see the type, it shows str, which means string. str is short for string. Okay, so now I've used triple quotes. To use triple quotes, use single quotes 3 times. So that is going to give you triple quotes, and it has still showed me string. So this is the basic idea of how we use string. Now let's see what are the uses of triple quotes. Single and double quotes are very basic. If you understand triple quotes, you'll understand single and double quotes. So the primary use of triple quotes is for doc strings and multi-line string. So right now these terms would sound like a terrifying concept, but these are nothing. Doc string basically is that tells function what the function does. We'll understand function, then when we will do function, we'll understand what it actually means. But right now you can just say that it is a manual for a function. It tells what a function does to the programmer only. It does not have to tell the interpreter or the machine. So it is for the programmer only. But that's the use of it. It tells what the function does. So I've written a very basic code. You might not understand this code right now, but it is okay. You don't have to understand it. So I've written, in quotes, I've written this function types hello, but it did not print it because it is a doc string. It takes it as a comment, so it does not print it. Comments are not printed as we see. So it's a comment, it is not printed. Doc string is basically a comment that tells what a function does. So right now, as you see that I've written a string, so I've copy pasted that string multiple times, but when I moved on to the next line, it came in black, which means it's not a string. Now that I've put it in triple quotes, it shows string. So that means we can use triple strings for multi-line strings. If we want multiple lines, we use triple quotes. That is the use of it. And if we use it wherein we don't declare a variable, we use it directly, it acts as a comment. See, I've uncommented the details I've written before and I've added it to triple quotes, and it will act as comment. It will not, on running this again, it will not print that. See, I told you. That's how it works. That's the role of triple quotes, to basically comment or for multi-line strings. Doc strings are kind of a comment only, which tells what a function does. So it's basically manual, as I already said. So there's one basic difference between a comment and a triple quotes string, that interpreter ignores the asterisk, but it does not ignore the triple quotes. Although it does not print it, but it does not even ignore it. So that's it. We've done the fundamental data types. With this, our fundamental data types comes to an end. We'll move on to derived in the next video. Until then, see you. Thank you for watching. See you soon.